Hello everyone, welcome to Semiconductor. One of my subscribers asked about wafer soak process, so I decided to make this episode for that. Thanks for comment and let's talk about it. I will explain a little more about wafer soak process based on blade saw, because there are lots of different wafer soak methods and blade saw is the most popular one. Before we start wafer soak process, there are some items we need to think about. Those are cut quality, productivity, and blade life. Cut quality is about chipping size and cup width. So, we need to select the best solution to minimize chipping and cup width. Productivity is about how many units we can saw per hour, and it should include the setup time as well. Blade life means how long we can use blade. If we can use blade only for a short period of time, we need to change blade more frequently, then spend more money to buy more blade. Also, we need to spend more time to set up new blade. All these things increase production cost, which is not desirable. Important criteria of wafer blade saw process are chipping size and cup width. We can have chipping at wafer front side and back side as well. Mechanical stress can be concentrated at the chipping point, then it can cause die crack. So, it is better to minimize chipping size. Cup width depends on wafer design, but trend is to reduce cup width. IC wafer manufacturers want to put more dies in one wafer because IC is expensive and more IC can increase profit of IC manufacturer. So we need to minimize cup width as much as possible. As you can see in the picture, saw blade goes through whole wafer thickness and partial tape thickness. If blade goes through tape thickness, it will damage underneath chuck table. To choose right blade and process parameters, we need to consider which material will be cut. Material hardness, material thickness, and depth of cut are key items to review. For example, glass wafer is harder and more fragile than silicon wafer. So, we need to choose right blade and process parameters, which is different from silicon wafer case. First, let's take a look about blade type. There are two major blade types, hub type and hubless type. Hub type blade has hub at the center and typically it is aluminum. It is used for applications which require minimum blade vibration. It is easier to handle by operator and has simple dressing. Hubless type blade does not have hub at the center, means blade only. It is used for applications which blade cooling is more important and it shows better blade cooling. Serrated blade is also called slotted blade and it has a slot on blade for even more cooling. For hub type blade, we need to check some important items in the specifications to choose the right blade. Those are blade outside diameters, blade exposure, blade thickness, grit size, grit concentration, and bond hardness. If we zoom in tip of blade, we can see exposed blade, and blade exposure is the length of exposed blade from hub. Grit are small particles inside of blade and used to cut material. Typically, synthetic diamond is the most popular material for grit, and sometimes boron nitride is also used as grit. Grit concentration is about total amount of grit in blade. Bond hardness is the hardness of bond material which makes grit stay in the blade. If you look at the blade specification from blade manufacturer, you can check these important items. We can check bond, exposure, grit type, grit size, grit concentration. Now, let's talk about bond type. There are resin bond, electroformed bond, and metal bond. Resin bond uses resin as the bonding agent. It means resin holds grit and form blade shape. It shows excellent cutting ability with minimum dressing. It is good for hard and fragile materials, but it has fast blade wear out and fast loss of edge geometry. Metal bond use sintered metal powder as the bonding agent. It means sintered metal powder hold grit and form blade shape. It shows longer blade life than others and even wearing with consistent cut quality. It is used for not super hard or not super brittle material. Electroformed bond is also called electroplated bond. It uses electroplating for bond. It shows very low blade wear, good edge geometry, and high accuracy. It can make ultra-thin blade thickness, but it needs a longer blade dressing process and blade cost is higher than others and cannot be used for ultra-hard and brittle materials. Its blade life lasts less than metal bond and resin bond. For grit material, as I mentioned before, synthetic diamond is the most popular material because it is the hardest material as far as we know. It cuts fast with smooth finish and consistent performance. It shows wear resistance and works well for all types of materials. For grit size, finer grit such as 20 micrometers are much smaller in size than coarser grit. It makes very smooth surface finish with minimum chipping on edges. These finer grit are usually used for lithium niobate, gallium arsenide, and optical materials. Coarser grit are much larger in diameters and used for fast cutting. These coarser grit are usually used for silicon carbide, zirconia, aluminum oxide, and other advanced ceramics and high metal content materials, which do not require a very fine surface finish. Grit size has considerable effect on cutting speed. Cut speed of coarse grit are higher than finer grit and will remove more material than finer grit. For grit concentration, high grit concentration means there are more amount of grit in the blade. So, it makes the blade to act harder and wear slower. It is used for cutting softer materials. In general, as the grit concentration increases, the blade's cutting efficiency and sharpness decrease. Low diamond concentration make softer and faster blade wearing and create better cut quality and surface finish. It is recommended and widely used for cutting ultra-hard and brittle materials. However, it will wear off faster than high concentration counterpart. We've talked about blade, and next one is process parameters. There are three key parameters: spindle speed, feed rate, and cut depth. For most cases, first two parameters are more important. Spindle speed is the blade rotation speed, and its unit is RPM, rotation per minute. And typically, it is from 10,000 to 40,000 RPM. Feed rate is cut speed, and its unit is millimeter per second. Slow feed rate means low productivity, but typically shows better cut quality. For cut depth, blade need to go through 100% of vapor, plus some amount of vapor mount tape, and should not touch surface of chalk table, not to damage sewing machine. So far, we talked about hub type saw blade, and let's talk about Hubless type blade. Most items are also applied for Hubless type blade, except its structure. As I mentioned, there is no hub at the center of blade for Hubless type blade. And there are 3 key parameters to select the right blade: blade thickness, inner diameters, and outer diameters. This is a little more about wafer saw process based on blade, and I hope this one can help you to understand more about wafer saw process. Have a nice day and see you again soon. Bye bye.